Objective 1 is to understand agriculture producers' climate information uses to improve climate change communication gaps between scientific communities and agriculture producers. To do that, I will identify climate data sources, formats, types, and accesses preferred by agriculture producers for information farm decisions and understand how producers comprehend climate information in cartographic methods. The theory to use The theory for objective 1 is elaboration likelihood model, which guided to find how high involvements and low involvements group to use climate information. The designed interview research used a non-random sample. I recruited agriculture producers through agriculture research and extension centers who were willing to spend half an hour to 1 hour for my interview. The first two sets of the questions were more structured to get an overview of the agriculture producer's demographic and farm operation information. The last sets of questions were more structured and open-ended to examine weather and climate data use. The reason to put weather data use is because previous studies mentioned that agriculture producers use more weather data than climate data. I worry that some producers do not use climate data. So in order to keep the conversation, I include weather data use. I can learn from their weather data use to compare with climate data use to get the differences. I can also learn their weather data visual representation formats to indicate their data visualization preferences. A second reason is that in current studies do not provide the information of how producers use weather and climate data, respectively. A total of 30 in-depth interviews were conducted in 2015 between May to December. Informed consent was obtained from each interview participant, and all interview data collected remain strictly confidential. Anonymity of the respondents was maintained and interviews were audio recorded and transcribed. Survey data was suggested for a better understanding of the spatial variation the climate data use. Interview results on climate data use and the climate cartographic visualization methods were used to generate this survey to gather data use opinions from agriculture producers. Questions are designed to gather climate data use among the agriculture producers. Survey questions begin with climate and weather definition at the beginning, then asks how often do you use climate data? If the producers do not use climate data, but still pleased to fill the survey to share some potential preferences of the climate knowledge. Then the survey will gather producers' demographic information, including their geographic location information for their farm, which county or counties they farm. A scoring system is assigned during a Likert scale from 1 to 5 for climate data sources, formats, types, and accesses. The data formats are accessed through several principles of climate cartographic design, including principles concerning map layout, visual hierarchy, visual variables. The survey link will be advised through Kansas Agronomy Department e-updates, advertised through Kansas Agronomy Department e-updates, email listserv, and postcards. Informed consent will be obtained from each survey participant digitally. A survey will be conducted using Kansas State Survey Service powered by Quantrix. Internet-wide statistics show that 80% of the internet users out of the total population in Kansas. An institutional review board application will be submitted to the Kansas State University Research Compliance Office in April 2016 for this survey. According to Kansas Farm Facts, there were 61,800 farms in 2013. In order to have a confidence level of 95% at 5 confidence interval, and the survey sample size needs 385 respondents. All survey data collected will remain strictly confidential. Survey data will be analyzed using our open source statistical package. Analysis of variance ANOVA will also be used to analyze the survey data, testing spatial and temporal differences that exist among producers for climate data uses within the Kansas Statistical District. The outcomes of the survey will indicate data use preferences across Kansas to provide data and visualization designing for the application. The goal of Objective 2 is to develop the climate decision support system based on the previous data use preferences research. I will use the climatological network data import into GeoDatabase and then finish the dynamic analysis with modeling and map application. 2 communication theories are guided for this application design. Framing theory will be used to support the communication text and value based on cartographic design principles. A clear visual hierarchy, simplicity, legibility, consistency, accessibility, and good composition. Framing can translate the science through scientific data visualization, cognitive, and cartographic design principles, making the invisible process of the changing climate visible while rendering the abstract concrete. I will tie into the survey results from Objective 1 to provide climate data and its visual products to meet the needs for agriculture producers. Visual communication messages should be simple, noticeable, understandable, memorable, and emotionally charged, with framing as a means of making sense of issues. Based on that, a second communication strategy is applied using construct level theory, CLT. CLT is a theory in social psychology that describes the relation between psychological distance and the extent to which people's thinking about objects and events is abstract or concrete. This theory is adopted in this research to understand what the perceived psychological distance influences construct level for climate information through geovisualizing methods at spatial, temporal, social, and hypothetical levels. It also targets spreading climate information with scientific, accurate visualization and cartographic interpretations that connect the dots from changes in farm-level weather patterns, environmental conditions, and extreme weather events to climate change, as well as successful adaptation strategies among agriculture communities that have already implemented solutions. So the Kansas Agroclimate website, the GeoDatabase that I learned from Objective 1 in using the GISO lab, the GIS server, learning from the visual methods that present everything in the web application. If needed, that mobile devices could be a way for dissemination. The potential interface that all datasets will be made publicly available online through the Geographic Information Systems Spatial Analysis Laboratory website as a cooperation with the Kansas Office of the State Climatologist. Objective 3 is designed to evaluate the climate data visualization methods and geospatial climate support decision-making system. Two criteria are selected. The first one is Farmer and Bolt 2004 application usability and effectiveness in the IPCC 2012 Special Report Evaluation Rubrics. Workshops and evaluation methods will be used. Mixed methods with thematic analysis, simple statistical analysis will be used. The anticipated results is for climate data use and climate literacy improvement among agriculture producers. Evaluation workshops lasts 2 to 3 hours, will be held in the Kansas Research and Extension Centers using a multimedia PowerPoint presentation with the application and products. Workshops will be audio recorded and transcribed and will be analyzed systematically. Evaluation methods is to use standard social science assessment techniques. To test the effectiveness of the workshop, pre- and post-workshop surveys will be collected. Questionnaire surveys will be designed for the workshop participants. It will comprise 2 almost identical sections. The first section will be completed before the workshop, and the second section will be completed immediately after the workshop. Part 1 will contain demographic information and some multiple choice questions, including the data exploration and representation methods. Part 2 will contain evaluation questions using the criteria mentioned above and some open-ended questions to get some comments of the application. Descriptive statistical methods will be combined and used to analyze the survey data. For data exploration and representation questions will be accessed using thematic analysis and a paired samples t-test to compare participants' data, consumption attitudes, and beliefs before and after the workshop. Informed consent will be obtained from each participant, and all data collected will be kept anonymous. The anticipated results through the objective 1 to identify suite of preferred climate variables. Objective number 2, the application tagged by credible and evaluated sources. With the whole system that I can tell the graphic visualization preferences, usability, interactive of application, increased usage of climate data in future farm management decisions, indirectly improve understanding of climate change to bridge the communication gap. Here is the preliminary results from interviews that help me to understand how the weather data use and climate data use to help understand for the data consumption.